I'm the math consultant for elementary, and Jackie Decker is our secondary math consultant. I just want to point out one thing. If you click on, or if you put in the which just got covered, sorry, the link there, you'll get a Google document or Google folder, sorry, that will have this slide presentation as well as any of the resources or activities that I've included in this presentation available to you. So these are our learning goals today. Today we'd like to focus on building to continue our understanding around key quantity and counting concepts. We want to practice naming and noticing some strategies that students use, and we will explore concrete ways to develop number concepts. I know within this Google Meet that we have lots of educators that work with a real range of learners and where they are in their understanding of number. So I ask you, as we're going through this learning today, that you think about how these early numeracy concepts might relate to where your students are in their number understanding. We're going to start with a little actually fun activity for us to do. I say fun, maybe not, but what I'd like you to do is think about where 1 billion goes on this number line. So we've got 0 to 1 trillion at the bottom, and if you could think about where you'd place 1 billion. So you've got a little bit of think time, and then if you could put your answer in the chat box, that'd be great. Thank you. Jackie, is anyone putting in there where they think 1 billion might go?
I am not seeing anything in the chat. Oh, I'm starting to see. I see one that says 2/3 of the way. So thanks for being brave and putting your answer out there.
So I'm just going to kind of show with my, actually, I'm going to use the pointer here. So about there, 2/3 of the way. Yeah. Anyone else have a guess?
We're saying, I see another one, middle or 3/4 of the way.
About there or there, yeah. Anyone else?
I see a 1/3 of the way also.
1/3 of the way.
And I think everyone is just quietly thinking about this question.
Okay, I'm going to be honest with you. We did this at a presentation one time, and I was a participant in the presentation, and I just kind of watched and waited till everyone else answered because I had no clue where 1 billion would go in 1 trillion. So 1 billion is actually 1,000. There's 1,000 billions in a trillion. So a billion would go right about here. This is hard. Lots of adults maybe have to think a long time about this or make guesses. Some people thought that the trillion maybe meant try, so 3. So we divided our line up into 3. A lot of people think of right in the middle half. The reason why, though, it's so difficult for us is that we don't ever really think about trillions or billions. Maybe we hear it on the news, but it's not a number that I myself personally regularly work with. So we do this activity just to remind us how difficult and how frustrating it is for some of our little ones to think about numbers to 10, numbers to 20, maybe even like that number to 100. Like what could be beyond 100? It just seems so abstract to little ones, and that's why we do this activity, just to think about, put ourselves in their shoes when they're just learning those little numbers that come so easily to us. To help us understand some number sense ideas, we're going to watch a little video by Fletcher, who's an educator from the United States. So he is from the States, so some of the grade levels that he puts up don't quite match ours, but that's okay. This is a progression of concepts that students develop as they learn about numbers. We probably don't ever think about this because we already know numbers, we get them. But it's important for us to understand these concepts so that we can pinpoint where students are struggling and then think about how we can help them.
Before we ever get to addition and subtraction, and long before we tackle fractions and decimals, there's so much understanding that needs to take place. So here I'll try to explain the progression of early number and counting. Well, before students come to us in kindergarten, they begin to see what numbers look like. I mean, literally. Check out these dice. Students know that there's 4, 2, 3, and 5, but they don't know that quantity. They're just simply calling out number names and matching them to what the things look like. They know that we have 3, 3, 5, and 4 on the yellow card. What they're doing is matching a number name to a visual pattern. This is a really big piece, but a lot of kids are able to do this before they come to us in kindergarten. This ability to recognize quantity without counting one-to-one is called subitizing. Some say sub, some say stew. I just say it's magic. But here, if we were to show the number 4, a student might say 4. Yes, they know the number name, but if you ask them to prove it, they might count them 1, 3, 9, 7. This is a perceptual subitizer. They cannot explain why it's 4. I think most of us are familiar with the conceptual subitizer that would say 4 because there's 2 and 2 more. In this early trajectory, we're talking about a perceptual subitizer. So as students are working on this idea of subitizing, they're simultaneously building their understanding of more and less. Let's take these 2 hands, for example. If we were to put some candy in each hand, and then we were to ask a student, which one has more? I think most students are going to say the one on the right has more. And they're able to recognize this because they can visually see and compare the difference. They can't tell you exactly how many more, but that visual representation of more, well, that ties back to what they're doing with subitizing. The students don't need to count to compare the quantities. If we were to take some candies from the right hand, put them in the left hand to where they're equal or almost the same, now we have a need to count. So when students come to us in kindergarten, we now know that they have this idea of subitizing and more or less that they've been working on. So from there, we introduce rote counting. Rote counting, well, it's kind of like this. As students are learning the alphabet, they might say LMNOP and have no idea that there's actually letters embedded in there. Rote counting, same thing. Students are just working on that count sequence, the reciting of names. So an example of that would be as if we asked a student to count from 1 to 6. They might say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We said stop at 6, but you know what? They can't. They have no idea where 6 is in that count sequence. Well, in kindergarten, students should be working on that count sequence from 0 to 100, forwards and backwards. I think most students in kindergarten have had exposure to a 100s chart or a 99 chart. But what about this one on the right? When the value increases, the numbers on the chart rise up. Now when we count up from 0, we don't go down, we actually go up. That might make more sense to kids. Something to think about. So as students are working on this idea of rote counting, we begin to introduce this idea of one-to-one correspondence. And to be honest, one-to-one correspondence, it's much more than simply tagging numbers to objects. Here's an example. If we ask a student to count 8 and place them in the bowl from a set, and they're able to do that, they're a producer of counting. They're able to do that one-to-one tagging to 8. Now, if you ask them how many were in the bowl, they don't know. They'd have to go back and recount them all over. A student that we'd ask how many didn't make it inside the bowl, well, they're a counter. They can count a finite set of a quantity. So for instance, there was 4 that couldn't make it. So we want to make sure that students are both counters and producers. And one way we can do that is by building this understanding of tagging, but not always with numbers. So here we have 6 bears, and we want to match each bear to a green present. This idea that's happening in one-to-one correspondence, it's really, really big, and we need to make sure that we devote enough time for our students to develop this understanding. So as students are working on rote counting and one-to-one correspondence, cardinality gradually makes its way into the conversation. What cardinality is when students are counting out a set of objects. The last number in that count sequence describes the quantity in the set. Students might count this pattern here of these pennies, but they might double count some. So now they use a counting strategy where they line them up and count from 1 to 8, and they know that they said 8 last, so that there's 8 in the count sequence. This was an example of a counter with the pennies, and on the bottom here with the rec and rec, we have a producer of 8, and they're able to tell you that it's 8 because of the last number. We then move on to hierarchical inclusion. Yeah, it's a really big word, but all that it means is that students understand that numbers are nested inside other numbers. So if we take that penny, for example, students would know that if you had 8 pennies, you must have 7 pennies. That numbers are nested inside the numbers. So if we ask students to put 7 inside this circle, do they need to count out 7 pennies, or do they just remove 1 and drag the set into the circle? The same idea with the rec and rec. Do students count out 7, or do they just know to remove 1 because 7 is nested within the 8? And at the final part of this progression of early numbering counting comes number conservation. The big idea here is that students understand that there's a decomposition of number. We might ask, are they the same? Students would say, yeah, we have the same number. But if we stretch out the blue row and ask which one has more, students might say the blue. This is at the heart of number conservation. It's about decomposition, that numbers can be broken apart, and that numbers, the whole, is made up from parts. So at the beginning, we talked about a perceptual subitizer. Well, here we have 3 sets of 4. Well, when students get to this piece in the number sense trajectory, they understand that that 4 is made up from parts. So now when we show students these dots and we show them these yellow cards, they're able to see that 4 just isn't a name, it describes the parts of a whole. Now we're getting to that conceptual subitizing. There's a whole lot happening here. One thing to remember, the turtle won the race. Thanks for watching.
Let's continue the conversation on Twitter.
So thank you for watching that. And as Graham Fletcher said, it's pretty complex that is happening in just learning how to count and thinking about number. So we have this is from his trajectory. It actually kind of goes in order of complexity on how students learn this. But I just want to highlight too, we have this in the folder that I shared with you, or in the link that I was shared with you. This is the one that we've actually developed from Limestone. It is adapted from the Guides to Effective Instruction, and it does go a little bit more in depth than some other things that he doesn't mention. So I just wanted to highlight that if you wanted to take a look at that. And we've also made the links, if you're an ECE, how these actually link to the kindergarten program. So moving on, I think what we're going to do is we're actually going to watch a student. This is a little guy from Limestone, and they're very short videos, like 7 seconds, so you just kind of watch really quickly. But what we're going to do is we're going to try to identify what quantity and counting concepts this child has. And then think about maybe what we don't see.
Prisha, before you begin that video, I just might highlight to folks that just underneath the video there, you've got a reference of all of those number, quantity, and counting concepts we just learned about, and they might want to look at those as they're deciding which one is in the video.
Yeah, thanks, Jackie.
1, 2, 3, 4, 5, 6, 7.
So I might just play that one again because he does it so quickly.
1, 2, 3, 4, 5, 6, 7.
Okay, and we're going to watch another video, same kid.
7, 8.
Can you do that again? Because I didn't see it.
Yeah. 1, 2, 3, 4, 5, 7, 8.
Okay, so if you could go into the chat box and maybe write down what you think the number, quantity, and counting concepts this child has, and maybe some that you're not seeing. And Jackie, you can just let me know when there's some things in there.
Will do.
Thanks.
And I just want to remind folks, we're going to start with what he does have, or what this child does have, and then we'll move to the concepts that we don't see yet. So I'm seeing that he does have counting in the chat box, Prisha, and I'm seeing that he does not have one-to-one correspondence yet.
Yeah. You might have noticed that. And so he actually, before we even get to one-to-one, it's called tagging and pointing. So he's able to point as he's counting, but he's not coordinating what he's saying. So some kids know that they should point to objects as they're counting, but they're not actually able to count along with that. So that's a little coordination issue that actually comes before even one-to-one correspondence. He did have that tagging and pointing, I think, to about maybe 3, or maybe even 4. I'm thinking 3. And then to the counting part, he can count. So that's he has something called stable order. So he understands that there's a sequence of numbers that we count by. Except in the second video, he mixed up 7 and 8, I think, or 8 and I think he did 7, 9, 8 or something like that. So I don't think he's got that really solidified, but I think maybe counting to 5 is really great for him. That's a little high, that's good. Anything else?
I just wanted to clarify before, when I stepped in to say we want to start with what he does have. The reason we ask you to slow down and do that, why we gave some quiet think time, is because as teachers and as EAs and as ECEs, we're really good at seeing what's missing, but sometimes slowing down and seeing what the child does have helps us understand what's next in their trajectory.
And thanks for highlighting that, Jackie, because I think actually with this student, exactly, the teacher was feeling like they didn't have any math knowledge at all. Like he doesn't know anything. And so then when we slowed down, we're like, actually, let's celebrate that he can take and point to 4. And now we know where to start working with them. Is there
Okay, I think we're ready to move on, Prisha. I'm not seeing any other comments in the chat.
Perfect. And this question too, I mean, we can't really see subitizing with this question. So if that, like, it depends the questions we're asking to what we might be able to see. So now I'm thinking, like, what am I going to do with this little guy? But I'm going to highlight a couple of things. I really think that before I move into the whole world of abstract, of the symbol of the number, I need to be working a lot with the concrete before I even move into the visual. So that's going to be a lot of using blocks, tiles, counters, whatever it is, and then moving into some sort of visual that they can use, like a 10 frame or a 5 frame, before we go to that abstract number. If you are working with older students, as numbers get larger and more difficult, like fractions or decimals, we need to remember that students actually need to build an understanding in this concrete world and then the visual before we just show them the symbol of like 1/2 or 3/4 or whatever. And that's how we're going to build all these other concepts, like the subitizing, the higher conclusion. All that comes because we spent so much time in this little world of concrete and visual. So for this little guy, I do want to support tagging and pointing. I want to build a stable order and some subitizing. So this is a really quick game. It's called Tug of War. It's one of my favorite. I've played it in like tons of kindergarten classes and they love it. Super easy to set up. If you don't have the game board, I just would draw on chart paper this image up here. But Jackie and I are actually going to play it remotely. So we're going to try this out. So I'm going to Jackie, are you in the slides?
I sure am. I'm ready to go. I'm going to win too.
Yeah. So the way you play Tug of War is you have a dice. I'm going to be player 1. Jackie's going to be player 2. I'm going to move to the right. Jackie's going to move to the left. And all you're trying to do is get my happy face all the way to the end. Within this slideshow presentation, I do have a dice. So I'm just going to roll a die. And I rolled a 1. So I'm just going to click on my happy face and move it over 1. Jackie, your turn.
Okay, I'm going to roll the dice. And you can't see, so you have to trust me. And I'm going to roll a 3. So I'm going to grab the happy face and I'm going to go 1, 2, 3 in my direction.
And you just keep playing. So then I could go again. Sorry, the dice. I got a 5. So now I'm just going to do 1, 2, 3, 4, 5. And that's it. You just keep playing until you get to the end. I have used 2 dice to make this a little bit more difficult, and we've just made the board longer. The subitizing happens by looking at the dice. And kids you watch to see if they count how many dots are on the dice at first, and then after a couple of rounds, they just will, no, that's 5, that's 4, that's 3, and so on.
And if you're wondering about the remote part, the reason we're able to play together is because we're in the same slide deck. You'll notice if you can just gesture to where my little icon is up there, Prisha, that little guy is me. And so we're in the same slide deck at the same time. And that's how we're able to play on the same slide.
So if you had a student that you wanted to play with this remotely, you can share the slide, they can get on it, and then you can both play. Go back to the bed. Graham Fletcher also, this is also found in the Google folder. He has created kind of a sheet of different games. They're actually pretty awesome. They're color coordinated to whichever concept you're trying to work on. So in this case, we're just looking at the red. So I just put in the red ones, but the full sheet is in that Google folder. And we're going to look at some subitizing games. And the first one is just called How Many? Basically what we do is we take some cards. I've got a list of cards here, pile of cards here. And I can split the deck, or I can just keep the deck in for myself, and I just flash the card. I'm going to give students think time. It's not like an automatic, like, let's go. It's let them think. If they can figure out the number, they get the card. That's the whole game. If in the Google folder, you will have the 5, 20, 10 frame cards, but then I also have created a little slide deck. I'm just going to get out of that. If you click on it, it'll ask you to make a copy, but this is what it looks like, and the cards are here. So Jackie and I are just going to play a little game of how many. Jackie, do you want the 5, 10, or 20 frames?
I'm just working on numbers to 5 right now, so 5 frame, please.
Perfect. So if I go to present, oops. If I click on the 5, it just takes me to the 5 one. So Jackie, can you tell me how many you see?
I see 5, but there's 1 missing, so I think that's 4.
Yeah. Okay.
Oh, and that's 1 less than 4, so I think that's 3.
Awesome.
Oh, and we've got 1 more than 3, so now we have 4.
Okay, so you just keep going this way with the cards. You can do the same thing with 10 frame cards and the 20 frame cards. Some ways that you can extend this game. One, I might be thinking about playing like almost like a war, just playing a war game. I also might think about playing a quick game of who has more and by how much. And the other thing about these cards that I love is that there's no dependence on number, of the symbol of the number. When we use these cards, it actually forces students to think about the quantity and making that quantity and that connection to the word 5 or 4 or whatever it is, so that they're getting that visual of what that actually means. Okay, so we have another student. This is another Lemson student. This is a student in grade 1.
Prisha, I'm just going to remind you to go back into present mode so we can see that video a little better.
Thanks.
You're welcome.
This is a little girl in grade 1, and it's a quick video again. And before we start again, just think about what specific number, quantity, and counting concepts this child has. And if you could write those in the chat box, that would be great. And again, below is the trajectory there of some of the key terms or concepts.
Count those kids for me.
2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
So how many are there?
12.
Wow, okay. Could you tell me how many are there now?
1, 2, 3, 4, 5, 6, 7,
On the whole bench, how many are there now?
8, 9, 10, 11, 12.
Okay. And how many are there now?
12.
12. How did you know that?
Because I counted.
Okay. So I'm going to show you a number. That one right there. What number is that? 6. Could you pull 6 cubes out for me, please?
1, 2, 3, 4, 5, 6.
Okay. Now, can you turn that 6 into this number for me? What number is that?
10.
So can you turn those 6 cubes into 10? Make that pile 10.
7, 8, 9, 10.
Okay. And now can you turn that pile into that number for me?
It's number 7.
1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8.
Okay, if you wouldn't mind just taking a couple minutes to add to the chat box what number quantity counting concepts you see or heard.
So I see in the chat cardinality.
Yep. Sorry, what did you say, Jackie?
Cardinality.
Cardinality. Yep, yep. So she understands that that's the last, she's not just pointing at the 12th pile. We said it's 12. She knows it's all of them. Yep.
Does anyone have anything else they're noticing that this child has? Okay, so another comment says, I think everything, great counting on, and number conservation.
Yeah, so this is a grade 1 student. She has a lot going on that I feel like she's got a lot of her accounting quantity concepts. The one thing that I maybe might me think I might need to work a little bit on is her higher conclusion moving backwards. So she had it going forwards when we asked her to take I think it was the 6 to the 10, but then when we asked her to go back from 10 to 7, she was close but wasn't quite sure. So sometimes a higher conclusion works both ways, plus or minus numbers. So that's actually maybe where I think I might work with her. Also, we asked her to make 10, and she had that pile of 12, and she just didn't notice to move the 2 over and know that that was 10. But everything else, yeah, she's got like the counting. She actually has like a little nice organization as well, which makes me think they might be using some 10 frames in the class, really help her with that. So what might I do for this student? Because I want to make sure that I'm also pushing the student to think a little bit deeper. So I just want to show you a quick game on a Rec and Rec. So I'm not sure if you've seen a Rec and Rec before. They're in a lot of schools. But there's also a digital copy that you can get into in Matthews. It comes up like this. The link is there, but it's also matthews.ca. And I wish actually I should have done it. Okay. So this is the Rec and Rec. We can add bars if we want, or we can take away bars, however you'd like to do it. And the way the Changeo game works is I'm going to ask a student to make a number. So in this case, I'll start with say 8. So the students, I'm watching to see if they know that that's just 8 automatic, or if they count every single little circle. And then I'm just going to go Changeo, and can you change that to 12? So I'm looking to see if my student starts again and counts all the way over again. Or do they know that I can do 5, 10, 11, 12? Or did they actually know from the 8, they started with the 8, sorry, that 2 more is 10 and 2 more is 12. And then I'm just going to change O again to another number. And I just keep going back and forth. And all I'm doing is building there, thinking about how far and how close numbers are from each other. And you're building on that higher conclusion. It's really simple, easy game to play. Another game, again, within the trajectory that Graham Fletcher was had created, he does have games that are for higher conclusion. And so Jackie and I are just going to, again, play a little quick game. This one is the plus or minus 1 or 2 war. So it's just like playing war, but we're going to decide together if we're going to do, we're going to use 10 frame cards this time. Jackie, you okay with that?
Yep, feeling good.
Do you want to do plus or minus? Do you want to do plus or minus 1 or 2?
+2.
Plus 2. So every time Jackie turns her card over, she's got to add 2 to whatever the card is, and I've got to do the same thing. So Jackie, what's your number?
So I see 1, so 1 plus 2 is 3.
Excellent. And I have 9 plus 2 is 11. So I won those, so I would take the cards just like you would in war. Jackie, that's your card.
I got a low one again. I see what you're doing, Prisha. I see 3. 2 more would make it 5.
Perfect. Oh, I've got 8 and 2 more is 10. So I get the cards.
I don't trust the dealer.
Sorry, Jackie.
And folks, we play it pretty quickly, but just a reminder that these are not speed-based games. The wait time, that quiet think time is so important for building understanding. And
you might even see, like when we play this game, I'll notice that students will add 2 more. They'll actually hold their finger right on that 8th one and then count on. If they are not able to see that right away, I might want to go back to the 5-frame cards. Just meet them where they're at and push them a little bit.
And in fact, within your class, you could be playing this very same game, and some students could be working with the 5-frame cards and others could be working with the 10-frame cards, but playing the same game. So you can differentiate very easily.
Yeah, or the 20-frame cards too. Yeah. Let's see. Oh, right, there we are. Another activity I might do with this student is because I want them to also think about the part whole of a number. So what are the different parts that compose and decompose a number? I just chose 8 in this case, but with her, I'd probably be doing this with bigger numbers. Shake and spill is a really simple game. You have a cup, you have double-sided counters, and I chose the number 8, so I'm going to put 8 double-sided counters in my cup. I empty my cup on the table, and I see what I've got. So in this case, I had 6 red, and I have 2 blue. So I know that 6 and 2 make 8. And then I just put the same 8 back in and shake and spill again and see what I get. Maybe this time it might be 5 blue and 3 red. All we're doing here is helping students see all the different ways that we can compose and decompose the number 8. As teachers, we do a lot of this for number 5 and 10, but we don't do a lot with the other numbers. So this is an easy way to really build that understanding of all the different numbers, either below 10 and then above 10. Okay, so I also wanted to show you one of my favorite tools, the Cuisinart rods. If you would like to go into the Cuisinart rods, in the slideshow, this is a link, but I'm actually going to ask you to go into the matthews.ca. So if you either click the link or you go to matthews.ca, and you'll see, maybe, should I show that page? Might be easier.
Sure, and I'm just copying that link into the chat.
Oh, perfect. Okay, so if you follow the link, but I will show you matthews.ca just over here really quickly. Because you'll see learning tools. And then they don't call them Cuisinart rods, they call them relational rods. So you do have the link, but they are also here.
You have to click on the open button on the right there, Prisha.
Thank you. And so when I go into this, what I'd like you to do is just take like a minute or 2 and just play around with the relational rods. I'm just checking our time. Oh.
I was just going to say, Prisha, I'm noticing we have 10 minutes, so we'll finish this task soon and then get folks into Minds Online.
Yeah, perfect. So let us know in the chat box when you've had a couple minutes to explore that. And maybe you just type in one thing that you noticed about the relational rods or Cuisinart rods.
So do give us a comment in the chat, folks, when you have had a chance to get into that tool and move it around a little bit so we know where you are at.
Maybe while you're just playing with it, I'm just going to tell you some of my favorite things about Cuisinart rods. I love them because they really help students visualize a quantity. So they can right away know that 10 is bigger than 1, and it looks like it's bigger than 1 by a lot. They also can fit perfectly in a 1 centimeter number line. So if you're relating these, this is the concrete tool to a visual tool of a number line, it's a really great connection. In older grades, we like to assign different values to them. They're lots of fun.
So Prisha, I really think we should get folks into Minds Online.
Perfect. Okay, so I'll keep going. Okay, so a couple activities I might do with this with my students, and this is actually part of the slide. This is a cloned version of using our rods. So you can just, oops, I'm gonna have to go out of present again, sorry. You can actually move the rods over and build whatever you want. So a question I might ask my students is to build 1 or more designs or 20. And I'm gonna give them the stipulation that they have to use more than 4 rods. And I can choose any number I want. I could choose 10, whatever number the students are at. Really simple activity, but lots of chances to do lots of different things with it. Some things I'm looking for, actually, when students are doing that, is I'm looking to see if they're counting on, if they're able to, do they need to put the 2 oranges visual to figure out what 20 looks like? Do they skip count? I'm just watching to see what counting and quantity concepts they actually have when we're doing this activity. I could also ask my students, how much is my design worth? They can make a design for me. I've got to figure it out. Lots of fun stuff we can do. Okay, so last but not least, today we do want to show you where there's lots more activities that you could access really easily that we've created for you. I'm going to get out of the presentation, and I'm just going to go into Limestone. So this is our Minds Online, our K-12 math Minds Online resource. So if you go into Limestone, and I'm just going to scroll down to the Minds Online button here, and I'm going to sign in.
I'm just going to slow you down there, Prisha. So Prisha started on the Limestone homepage, like the regular Limestone website. If you can go back there, Prisha. And so that's when you just Google Limestone, limestone.on.ca, that's where you land. You scroll down and show us where that Minds Online button was. Can you put your pointer back on? Oh, no, you're not in present.
Yeah, sorry.
Okay, that's okay. Yeah,
it's right there. I click it. You might have to log in like I was directed to, but now I'm logged in. You can see my name up there. This is the educator homepage. It's different from what the students will see, but this is the educator one. As you scroll down, you'll see that in our homepage, we have some LDSB developed resources. So if you click on that, these are resources that you have access to. All you need to do is sign up. So today, we're going to look at the K-12 mathematics. You simply click it, and then you would click the enable access. I'm not going to click that because I'm already in it, but if you click that, then you are in. And once you're in,
it'll just take a couple more clicks after that to register, but you're just registering to access the resource.
Once you're in, you will see that it does come up on your side here. This is what it looks like here. It's pinned there, but then it's also up in your waffle. So your waffle is just at the top here. And all the courses I've signed up for are there. And the math one is right here. When you go into, this is the front page, you will see that we do have a video that highlights the Minds Online resource. We do have a picture of our math Limestone vision of what we think an effective math program looks like. And then we also have up here the different resources. So I'm just going to click on elementary. And there's lots of stuff in here. The things that I think might be beneficial right away to you is the fluency games and activities. So if we click on this, you'll see number one, we've got a video, or sorry, a slideshow about some of the math games for remote learning. These are directed kind of to older grades for students that are pretty comfortable using technology. But then here we have, for example, our number, quantity, and concepts. So if you click on any of these links, it'll take you to, so I'm just going to show you supertizing, for example. Lots of different games and activities that you can do to support students. If I click the link, they are all written out for you, all the instructions on how to play. And then we already actually, like, for example, .bingo, we wanted to make sure that you had the pre-made cards. So all you'd have to do is click there and you can print them.
So, Prisha, I'm just going to answer a question that was in the chat.
Yeah.
Maria asked, and I'm really appreciative of this clarification question. Maria said, so just to clarify, are these resources readily available to use through Minds Online with students? So yes, so these are, most of these resources are in a Google format or other, and all you need to do is once you've clicked on those, you just make a copy for yourself. So if you're familiar with Google Docs, once you're in a Google Doc, so Prisha, can you go to one of those games you just had?
Yep, sorry.
If you can just go into that game, once you have that Google Doc open, if you just go up to the file on the top left, and if you click on make a copy, you can make a copy for yourself. You can share it with students online. When you're in the classroom, you can print it for yourself so that you have all the materials and all the instructions for yourself. And Prisha, while you're in there, can you also show folks the professional learning section of the content? Because that's where we're going to put this slideshow and this recording.
Yeah. So I'm just going to close this. But I just, well, the other thing I just wanted to highlight is in the Fluency games is that we also have addition, subtraction, multiplication, and then all the cards. So like number cards, the 5, 10, 20 frame cards, anything that you would need. And we even have a video on how to make a homemade spinner. Thank you, Jackie. She made that. And then, so I'm just going to click that to close it. And then down at the bottom, we do have professional learning. And this is where our webinars will go. Is that where you're in the webinars June 2020?
Yeah, so tomorrow the resources will be in there.
Yeah. And I just also want to highlight some web links as well. We do actually have some games in here as well. What? I thought we did. Nope,
Back up to the top. Back up to the top. Ideas. Nope.
Sorry.
At the top of web links, ideas and tools for remote learning. There are a few things in there too.
Yeah. So if you're looking for some ideas for remote learning, there is some links in there as well. And that's our presentation. So thank you so much and for joining us today. Do we have a couple of minutes if there's any questions, Jackie? Or
we do. It's 1:45 now. Prisha and I are hosting another webinar at 2 o'clock, but we have a few minutes if folks want to either turn on your microphone and ask a question or ask the question in the chat. And I think it's also important for you to know that Prisha and I are both just an email away, and we love to connect with other educators. So if you ever want to pop us an email, we can organize like a Google Meet like this, or we can email you back, whatever works for you.
I don't see any other questions. Okay.
No. Thanks so much for joining us, everybody. So Prisha, I think we'll just stay till the very end and close out the meeting just like we would if it was our class.
Yeah. And I stopped sharing, right? So you just have my...
You did. We just see your bright pink P, or it's pink for me anyway.
Yeah, I should put a picture there, but I have to wait till the COVID hair is done.
Okay, it's just you and me, so I'm going to stop the recording.
What did she mean by you can use the grid to help